Hello everyone, I'm Paul and today we're solving problem 2929, distribute candies among children 2. This one is medium and here I will show you how to visualize and solve it, so keep watching. The description is simple. We are given two positive integers n and limit, and we need to return the total number of ways to distribute n candies among 3 children such that no child gets more than limit candies. And of course here we have the constraints, and we know that n and limit are both smaller or equal to 10 to the power of 6. This means we can't do a triple for loop. We need to think about something more efficient than big O of n cubed. So the best way to solve this, or at least for me, it's through visualization. So now let's go with an example, and now we'll show you visually how can we solve this in big O of n time complexity. Let's say n is 5, meaning we have 5 candies and the limit is 2. And we will iterate this from left to right with an I pointer, because remember we are trying to find a solution that runs in big O of n time complexity. So first the I pointer is here at index 0, and we will use this I pointer to fix the amount of candies that we are giving to the first child. First, we are giving no candies to the first child. This is empty, and we have 5 available candies. But the problem is that we have only 2 remaining childs, and each child has a limit of 2. So we can give 2 candies to the second child and 2 candies to the third child. This means we can give 4 more candies, but we have 5 available candies. This means that we can't add any combination if we give no candies to the first child. So now we update I, meaning now we are giving 1 candy to the first child. And we have 4 available candies to the next 2 children. So we know our limit is 2, so we can give 4 more candies as a maximum, and we have 4 available candies. So here we will be able to add some combinations to a result. Now we know that after giving 1 candy to the first child, we have 4 available candies. And here we will only focus on the second child. And specifically, we will focus on 2 things. How many candies can we give to the second child at least? And how many candies can we give to the second child at most? Let's first focus on at least. Let's say we give the maximum amount of candies to the third child, meaning we give 2 candies to the third child. So the third child has 2 candies now. This means that at least we can give 2 candies to the second child. And now let's focus on at most. We can give to the second child at most 2 candies. Okay? This. So remember, now we are trying to get the total number of combinations. So we can take at most and subtract at least and add 1 for the current combination, and we can add that to a result. So in this case, 2 minus 2 plus 1 is 1. So our result is now 1, and we update I. Now the I pointer is here, and this means that we are giving 2 candies to the first child. And we have 3 available candies for the next 2 children. So now we will focus only on the second child as we did before, and we are specifically focusing here in at least. So here we will simulate that we are giving the maximum amount of candies to the third child. We're giving 2 to the third child. This means that at least we can give 1 candy to the second child. So at least is 1. And At most, we can give 2 candies to the second child. This and this. And now we have the information to add the combination to a result. We need to do at most minus at least plus 1. So 2 minus 1 plus 1 is 2. This means we add 2 combinations to the result. So the result is now 3, and let's see what this means here. This means that we can give 1 candy to the second child and 2 candies to the third child, or we can give 2 candies to the second child and 1 candy to the third child. That's where the 2 comes from, and that's why the result is now 3 when I is fixed at index 2. So now we update I and we repeat the same process. Now the I pointer is here, and this means that we are giving 3 candies to the first child, but 3 is bigger than the limit, which is 2. So this is where we end the loop and we return the result, which is 3. Now remember, time complexity for this will be big O of n because we are iterating this from left to right, and space complexity will be big O of 1 because we are only using variables with integers here. So now let's go with the code and hopefully you will get the idea. We will call the result for this one combinations. This is initially 0, and finally we'll return combinations. And here in between we'll iterate candies, so for I in range we'll take the minimum between n and the limit for each child. This is because we don't want to run out of candies. Here we add a plus 1 because this is included, and we start from 0 because we can give 0 candies to the children. And now, after the first child, this is n minus I. And if after first is greater than 2 times limit, we continue, because in this case some child will get more candies than the limit, so here we continue. And now we are focusing on the second child, so second at least and second at most. Second at least is after first minus limit, and if this is negative we want this to be 0, so we can take the maximum between 0 and this, and second at most is the minimum between after first and the limit. And finally we add 2 combinations, second at most minus second at least, plus 1 for the current combination. So this is it for the code, and now let's submit this and see if it works. And as you can see, this works. There is a more efficient solution that runs in big O of 1, but that involves a formula, and I think this one we just saw is more intuitive. So this is it for the code. If you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.